Today's lesson is on Chapter 10, Section 1, Line and Angle Relationships. Now I've split this chapter up into two parts, so this is going to be Part 1. We're going to start with talking about lines. A line is shown like this on a diagram. As you can see, it's got arrows on both ends, and it's going to run through a series of points. This specific line just runs through points A and B, but your line can run through more points than that. If you take this line and you were writing it in text, you would just have A, B, because those are two of the points that it runs through, with the little miniature line on the top. It does need to have the arrows on both sides. The arrows represent that the line extends forever in both directions. Okay, now on to some specific types of lines. First of all, we're going to talk about parallel lines. Parallel lines never touch because they have the same angle to the line. Or, now that we know about slope, we can think of that parallel lines as having the same slope. So they're never going to touch each other. Parallel lines are shown like this on a diagram. You've got two lines, and they're going to be named with lowercase letters, and those names of the lines go at the end of the line somewhere. So you've got line A and line B in this drawing. If you were writing in text and you wanted to say that two lines were parallel, you would write it like this: A for line A, and then two straight up and down lines that look like parallel lines, and B. Now these lines, when you write parallel, they don't have the arrows on them, but you still should know that that means that the lines, or they could be line segments, which don't go on forever, but either way, they are parallel. Okay, now talking about perpendicular lines. Perpendicular lines intersect each other at right angles. So they're going to look like this. As you can see, we've got our square to show a right angle, and we've got our lines labeled line C and line D. To write that they are perpendicular in text, it would look like this: C and then a little upside down T to show that there are two right angles there that are made when they intersect, and then D. So line C is perpendicular to line D. Okay, now let's talk about angles. An angle is formed by two rays with the same endpoint. Where the rays come together is called the vertex. So if we look at this angle, we've got ray AB and ray AC, and they come together at point A. So A is the vertex. You can also see there's a little 1 inside the angle, and sometimes your angles are given a number, so we could call this also angle 1. Okay, there are some specific ways we can name this angle. The first one is angle A, and that's what that little sign that looks like a cute angle is. It's angle. So angle A, so you can just name it by the vertex. And this can be done when it's not confusing as to what angle A might be. If you have numerous angles that their vertex is A, you need to be more specific. So some ways you can be more specific is going from one side of the angle to the vertex and then out to the other side. For example, angle BAC. And you can go in the opposite direction and say angle CAB. Also, if you have a number given to your angle, you can just say angle 1. All right, when we measure an angle, to show measurement, we're going to put a lowercase m in front of it. Here's an example. The measure of angle A equals 80, and that would be 80 degrees. Angles are classified based on their measures. This part should be a review for you. An acute angle is an angle that's less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is in between. It's bigger than a right angle, but it's not quite a straight line, so it's in between 90 and 180 degrees. And then our straight angle is exactly 180 degrees. Then we have some angle pairs, when two angles are put together and they are a specific type of angle pair. The first one is vertical angles. Two angles that are opposite each other when two lines intersect. So you can see that we have two lines intersecting. It looks like an X. So we're going to have pairs of vertical angles. Our first pair of vertical angles would be angle 1 and angle 2 because they're opposite each other. Our next pair of vertical angles would be angle 3 and angle 4. When you have vertical angles, they are always going to be congruent, or in other words, the same number of degrees. So if angle 1 is 120 degrees, angle 2 is also 120 degrees. If angle 3 is 60 degrees, angle 4 is also 60 degrees. That's going to be important to remember when you're working on your problems tonight. We also have adjacent angles, or angles that are next to each other. So two angles have a common side. For example, here we've got angle 1 and angle 2, and they share the side in between them. So they have a common side and a common vertex. They both come together at the same point. You can see angle 1 and 2 make a straight line. They make a straight angle when you put them together. Angles 3 and 4 do not. And it's okay, you can have adjacent angles regardless of what their angles measure up to in the end. Okay, we can also have complementary angles. And now these are two angles whose measures specifically sum to 90 degrees, or the two angles together make a right angle. They are called complementary angles. We then also have supplementary angles, where the two angles add together to be 180 degrees, or they make a straight angle. When we have adjacent angles, we can sometimes add them together. So in this picture below, the measure of angle AOB plus the measure of angle BOC gives us the total measure of AOC. So if AOB is 83 degrees and BOC is 62 degrees, then AOC must be the sum of those two angles, or 83 plus 62, which is 145 degrees. We're going to also be working with some algebra, or in other words, we're going to have variables in some of our problems. Here we have two angles. You can tell that they're supplementary. Measure of angle 1 is 5x minus 8. Measure of angle 2 is 4x minus 1. So we can find x because we know that they are supplementary angles. In other words, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We're going to plug in the expressions given for angle 1 and angle 2, and we'll say 5x minus 8 plus 4x minus 1 equals 180. We then combine like terms to get 9x minus 9 equals 180. We add 9 to both sides, and we get 9x equals 189. Then we divide each side by 9, and we find that x equals 21. So how does that help us? Well, once we know what x is, we can figure out what angle 1 is. We just take 5x minus 8, and we plug 21 in for x. That gives us 105 minus 8, which is 97. You could do the same thing for the measure of angle 2, just plug x in. Or you could, once you had the measure of angle 1, say, well, I know that angle 1 and angle 2 equals 180, and just say 180 minus 97 would give me my answer for angle 2. Okay, that's the end of our notes for today. You can either replay these or go back and watch parts if you need it. Otherwise, you can start on the homework assignment for tonight.